Deer Creek Audio, your trusted technical resource.
This video describes integrating and tuning a subwoofer into your 2.1 or 2.2 system using the Mini DSP 2x4 HD, SHD, or Flex, referred to as Mini DSP. Properly integrating a subwoofer, or even multiple subwoofers, into your stereo system is one of the most powerful ways to increase clarity, depth, dynamics, and all the attributes audiophiles associate with a high-fidelity full-range system. The primary goals of subwoofer integration are optimization of level, crossover, and delay settings, seamless integration of the last audio spectrum octave, elimination of excessive driver excursion and heat dissipation in full-range speakers, and finally, clarity, resolution, and impact. Room EQ Wizard, or REW, is used as a tool during the Mini DSP plugin setup. Once the initial setup sections are completed, your system will be optimized to perform a successful Dirac Live project. If you are building a 2.1 system, your subwoofer will need to be driven monoraily by the Mini DSP. If you are building a 2.2 system, you have the choice of a pair of monorarized subwoofers or stereo subwoofers associated with the full-range speakers. A 2.2 monaural setup can be beneficial in cases where aesthetics dictate the location of the subwoofers, or when the full-range speakers have large subwoofers. A 2.2 stereo subwoofer system would be used when the subwoofers are located in close proximity to the full-range speakers. Let's take a look at some typical hardware configurations tailored specifically to Mini DSP products. Quality cables in good condition and of proper length are essential for this project. Select the proper USB cables to allow for convenient access to the user interface PC and for the microphone to move freely around the listening measurement area. Be sure that all of the subwoofer cables are shielded, low loss, of adequate length, and securely connected. This image depicts a typical 2.2 setup. A 2.1 system with a single subwoofer will use output 3 only. At this time, you can check that the built-in level, equalization, inversion, and crossover frequencies of your subwoofer or subwoofers are either bypassed or set to nominal. REW signals generated in your computer will be sent digitally to the Mini DSP via USB. Your subwoofer should be set according to these parameters, so as to not interfere with the crossover, gain, and delay parameters that will be set up in the Mini DSP plugin. Generally, subwoofers can be placed against the rear wall beside the main with the full-range speakers pulled out for imaging purposes. Before proceeding with tuning, it's a good idea to experiment with various subwoofer positions and orientations depending on aesthetic and room limitations. Use REW to see the effects of the changes in position. Regardless of where the subwoofers end up, their location can be compensated for in either a 2.1 or 2.2 system by adjusting the relative delay between the various speakers. Using the Mini DSP plugin dashboard, you will configure the routing, crossover, relative level, and delay settings appropriately for your system. For a 2.1 system, your subwoofer will need to be driven monoraily using output channel 3. Typically channel 1 is used for left, and channel 2 is used for right full-range speakers. You also have the opportunity in the routing matrix to adjust relative channel levels, as shown in the highlighted boxes. A 2.2 monaural setup can be beneficial in cases where aesthetics dictate non-symmetrical locations, or when the full-range speakers have large woofers. An added benefit of monaural subwoofers is the ability to cancel out room modes that otherwise might be present in the stereo setup. A 2.2 stereo subwoofer setup would be used when the subwoofers are located in close proximity to the full-range speakers. This is also the preferred method with subwoofers that have higher crossover frequencies, such as 100 Hz or higher, or with subwoofers that were designed for direct placement underneath full-range speakers. Determining the most effective crossover between the main speakers and subwoofer or subwoofers is a task that can go beyond applying symmetrical textbook high and low pass filters. We have found in our testing that asymmetrical filters' slopes and shapes can produce significantly enhanced results. This requires experimentation, listening, and measurement. A textbook example of a crossover is the symmetrical 80 Hz Butterworth 24 dB per octave. This is commonly found in audio-video receivers with large main speakers. This next example is for a crossover between a 12-inch full-range speaker and a high-powered 15-inch subwoofer. What's notable is the soft high-pass slope for the mains, and sharper low-pass slope for the subwoofer. The soft high-pass helps to eliminate low bass room modes. This graph depicts the same crossover scheme as found in the second example, and adds high and low frequency band edge cutoff filters to optimize amplifier and speaker performance. These get added after your Dirac Live project is complete. To continue learning about how to simplify the integration of subwoofers into your audio system, visit our tech blog at deercreekaudio.com/tech-blog, or stay tuned for additional videos on this topic.